Assalamualaikum warahmatullahi wabarakatuh and good day to all. My name is Yusmardia binti Yusuf and today I would like to present my paper which is entitled Translation of Division Algorithm into Verilog HDL. And this slide presentation is prepared for International Symposium of Engineering Technologies 2016, ISET 2016, which is organized by University Teknologi Mara Terengganu. This paper deals with the design of 16-bit division algorithms programmed by using Xilinx ISE 14.4 software for translating the arithmetic operation for division operation. In recent, many researchers have proposed the algorithms to carry out the computation task in hardware instead of software with the aim to increase the performance of computation. We explain and translate the non-restoring method for division operation. This method is simple to implement since it requires only adder or subtractor in each iteration. Hence, it does not require any other hardware components such as multipliers and multiplexers. The algorithm is translated into Verilog HDL that's simulated using iSym simulator and then synthesized using Synopsys Design Compiler. The system will only operate unsigned binary division, hence producing in fixed point value. In the world of digital signal processing, the division operation is widely used, for example, in wireless signal processing, image processing, and computer graphics. Mostly, the algorithms are implemented using fixed-point arithmetic due to expected area and power saving. In many computer applications, division is less commonly used than multiplication, subtraction, or addition and takes much more longer to compute. Division is the most complicated of all the elemental operations, whether to implement the algorithm in hardware or software. However, it has been shown that ignoring its implementation can result in significant system performance degradation for many applications. There are a number of binary division algorithms such as multiplicative algorithms, approximation algorithms, Chordic algorithm, and continuous product algorithm. Fixed-point arithmetic is regularly used in the calculations because of the costing, since floating point calculations could significantly increase the size of the design and make it more complex. However, the existing solutions for the fixed point division are limited in terms of input and output width of the modules. Among the solutions is the Xilinx IP core divider, which is presented in paper 3, which is entitled Implementation of High-Speed Fixed-Point Dividers or FGA. There are Radix 4, 8, 16 and even 256 algorithms which are faster but difficult to implement. The disadvantage of floating point representation are slower and less precise than a fixed point. There are three basic components for floating point representation: mantissa, exponent, and sign. Based on Goldsmith's algorithm, the division operation associated with FMA design for single precision floating point has been proposed in the paper entitled for IEEE Standard for Binary Floating Point Arithmetic. There are two problem statements have been recognized, which are: the floating point representations are slower and less precise than the fixed point. Second, the available division algorithm is more complex and utilizes a lot of hardware resources. The objective of this paper is to design a fixed point of 16-bit division algorithms and to translate the division algorithm into Verilog HDL. The binary division algorithm is aimed to perform fast division operations and to enhance the performance of hardware division. Some of the proposed division algorithms by the previous researcher include Western division, SRT division, and Nikilam Sutra, which is part of the Vedic architecture. The table shows the different division algorithms that I've mentioned before. First division algorithm is restoring division. It is the fixed point fractional numbers and same as the traditional division operation, also known as paper and pencil method. Secondly is the SRT division, which is proposed by Dura W. Sweeney, James E. Robertson, and Keith D. Tosher. It is fast algorithm for two's complement number that use the technique of shifting over zeros for division. And the SRT division is the basic algorithm for radix to SRT division. Next is the Nikilam Sutra, and it is based on ancient India Vedic mathematics. It involves the addition of numbers, which is very much different from the traditional division technique, and it performs only small digit multiplication, no subtraction, and no division at all. The non-restoring algorithms come from restoring division, and it calculates the remainder by successively subtracting the shifted divisor from the dividend until the remainder is in the appropriate range. The method is referred from the paper as 9 as explained in table 2. Assume that we have D, which is dividend, and X is the divisor as an input data, Q is the quotient as division result, and R as a remainder. The methods of the non-restoring algorithm are explained in table 2. From the algorithm, it can be concluded that if the result of subtraction is negative, 0 is selected as the quotient Q. On the other hand, if the result of subtraction is positive, which gives 0 as a difference, quotient Q is selected as 1. In this paper, the Verilog HDL codes for division are generated and simulated using Xilinx 14.4 ISIM ISE. The Verilog HDL code is broken down into modules which deal with the division of 16-bit dividend and 16-bit divisor. We choose the non-restoring algorithm because it is simple to implement since it requires basic adder or subtractor operation, and the shifting process, which is to the left or right in each stage of calculation. Hence, it does not involve other hardware components such as multipliers and multiplexers. The top module connects all of the input and produces output as shown in figure 2. The simulation result of 16-bit fixed point division algorithm is shown in figure 3. It is clearly shown that the system needs 17 clock cycles so that the output for 16-bit input is in the ready state. Ready state here means that the enumeration stage is completed. We consider the division of 16-bit two fixed point numbers, which are 32768 and 158, fed as the input, dividend, and divisor respectively. The desired output of quotient is 200 and remainder is 62 is shown in figure. This proves that the calculation executed by the Verilog HDL code is valid. The simulation performed the calculation through the iteration per bit value until all the bits for quotient and remainder is determined. The Verilog HDL code for division is then synthesized using the XC6VLX240T device with the package of Vertex 6 FPGA family. Implementation and the implementation clock frequency is 10 MHz. The characteristic of the device as listed in table 3. the table 4 shows the total hardware required for the implementation in FPGA. The 16-bit non-linear method only utilizes small resources as compared to the SRT division proposed in the paper 11. And the authors of that paper conclude that the computation time is faster but difficult to implement since it consumes a lot of hardware resources. The non-restoring division algorithm is presented in this paper. This algorithm is implemented in Verilog HDL and synthesized by using Xilinx 14.4. Our aim is to focus on the simplicity of the algorithm, which is easy to translate into Verilog codes. This is because the non-restoring method only involves the basic addition and subtraction and shifting process, which is left or right. Hence, this method can be implemented for any value of binary numbers for division operation. However, this algorithm has limitation on the latency because the hardware needs to calculate the number in sequence or per bit to converge. Means that the higher the bit being processed, the longer it takes to calculate the output. Later in the future, the parallel method will be implemented for division algorithms so that the hardware is improved in terms of speed calculation. That's all for my presentation. Thank you.